Good morning, good afternoon, or good evening. My name is Jason Dustle. I am here from Murideo, and today, very exciting new product. We're going to be talking about the all-new 8K Fox Hound HDMI test kit. Before we get started, I just want to let everybody know that there is a question box in the GoToWebinar software. If you guys have any questions throughout the presentation, or just any questions in general, feel free to type those questions in. I will do my best to answer them as we go along here. And of course, we'll leave some time at the end for any last-minute questions. So before we get started, let's go ahead and before we get started, I'm going to bounce back and forth in between some slides and doing some sort of hands-on demos. So again, as you guys are going through the presentation, feel free, let me know if you have any questions. So as of right now, you should be able to see my PowerPoint screen. If you can't for any reason, use that chat box or use that question box and let me know, but it looks like everything's good to go. So again, we're going to talk today about the 8K Fox Hound generator and analyzer kit. This is something that we have had in the past, but in a 4K version. And this is sort of the next evolution, is going into 8K. For a few years up until now, 8K was always sort of in the pipeline. But guess what, guys? It's here. We have 8K displays here in the office. We're starting to see them more and more out in customers' homes. We're starting to see some AVRs and other devices that can handle HDMI 2.1 and 8K. And we're going to be seeing some sources here pretty soon. I've actually got one here with me. Eddie from the Netherlands says present. Hey, Eddie, how are you? Great to hear from you. So, okay. A little bit about Murideo. If you're not familiar with our company, if you are, thank you so much for joining us. I know we have a lot of loyalty and I see a lot of familiar names in the attendee box, so thank you guys so much. If you are new to Murideo, a little bit about us. We've been around since 2011. We started off in the display calibration world. Our CEO, Jeff Murray, and his son, Matt Murray, who's our CTO, come from a long history of things like ISF calibration. Jeff had a long history from a company called Sencor. 2011 rolls around and we knew that eventually the HDMI 2.0 spec was coming with 4K and HDR and all that fun stuff. And there was a kind of a hole in the market. So Jeff and Matt and some other partners decided, okay, well, let's go ahead and get in front of this 4K HDR stuff. And that's where we came out with our first Murideo generator. Since then, we've been doing our best to stay kind of ahead of the curve, if you will. And here we are now with not only 4K HDR under our belts, but also with some 8K stuff. Our goal is very simple. I say this a lot, so if you've heard me speak before, this is going to be a repeat. But our main goal as a company is to take a lot of headaches and to take a lot of stress off of the installers and the people who are working with this stuff every day. Not just installers, but also manufacturers and people who are doing reviews and things like that. The big problem without test equipment is you have no idea what's going on with the signal sometimes. So if you're an integrator and you're trying to troubleshoot a system, or maybe you're setting up a system, these tools come in very handy. Mainly what we're going to be talking about today are some of the different methods that we use for troubleshooting and testing cables and stuff like that. Again, our whole goal is to make your guys' life simple who are working out in the field and working in labs. Our technology, again, I can't repeat this enough. We try to stay ahead of the game as much as we can. We're very proud. A few years ago, we worked with HDMI.org, and if you check the website, we are an official HDMI test equipment manufacturer. So just a few things about us. I do like to give that little intro just in case anybody is new to the company. A little bit about me, Jason Dustle. I've been with the company now for a little over 5 years. Started tinkering with this stuff as a little kid, and when I was old enough to work, I decided, hey, this would be a cool job. So I bounced around to a couple of different companies, not too many, but I've been doing AV type stuff since the late 90s. One thing that I really went down the rabbit hole with was display calibration. I started calibrating displays in about 2007 or 8. Did that for about 7 or 8 years straight. Did thousands and thousands of displays out there in the world. I've been teaching ISF since about 2012. I've been teaching H2-Base-T since like 2016. I've gone through the CTS certification, dealer scope 40 under 40, and if you've seen any of the work we've done on the R10 committee with CTA and CEDIA, we do a lot of like recommended practice papers and things like that for the installers out there. So enough about me. A few little stats that I always find super duper interesting. This was a survey survey by CEDIA, who were asking questions of integrators about HDMI related issues. Now these stats are a little bit older. This was from I think 2018 or 17. I would suspect that the numbers are a little bit different here, but I would assume that they are very similar. And some of these are kind of mind-blowing. 66% of the installers that were interviewed said that most installations involve HDMI components. I would guess that number is much higher now. I would also guess that a lot of these installers may have more of an audio background, so HDMI might not be involved. If I had to guess, I'd say that number was maybe not 100, but getting pretty close to it if it's not 100. 57% of the installers said that installations involving HDMI components take a great deal more time, especially when you're doing distribution. That seems to be holding true. I talk to integrators all the time who are running into HDMI issues, which is why we're here. About half of the installers said that if they're using HDMI in the system and HDMI devices, that about half of those installs are going to have to do a return visit for some sort of troubleshooting, or maybe something's not working, so you got to go back. 83% of installers, this is a big one, they've had to take steps to simplify installations that involve HDMI components, and 82% said they actually had to take HDMI components out of the system to make the system work. This is still something that I'm hearing that's pretty common. In fact, there's always kind of this long-running joke where people say, "Man, I wish we could go back to component video because it just works." And that there's a lot of truth to that, but we are severely limited with component video on the video quality. And of course, you have to think about things like HDCP, which was one of the main reasons why HDMI came along. So simple connection, it's audio and video, uncompressed. It's designed to be plug and play. It isn't always plug and play, and some of those things that we'll talk about today. So why do you need this test kit? Number one thing is to save time, and time is money. This is one of those situations where you show up to maybe troubleshoot an AV system, and rather than swapping out the receiver, swapping out the TV, and just sort of guessing at what the problem is, that can cost you a lot of time and a lot of money. Also unnecessary returns. If you're an integrator out there, but you're also a dealer, you have to think about all the installations that you might do where the customer just says, you know what, I don't like this TV anymore. It's not doing what I want it to do. I'm going to go ahead and return it. So now the integrator slash retail has an open box TV, and it didn't have to be like that. There was probably nothing wrong with the TV. There was probably something going on, in between the TV and the source, something maybe with the infrastructure. So we never want returns, so we're going to try to avoid that. Again, avoid additional truck rolls. Again, that's time and money. I've been talking to some integrators over the past, I'd say about year or so. It was pretty interesting to learn this, but when I was in the field from 1999 till about 2012, doing installs all day, every day. In those days, the average truck roll to go troubleshoot a job, for example, was about $150, and that seemed to stay steady for a few years. But I'm talking to integrators on the phone every day. We're seeing them at the trade shows like CEDIA and Infocom, and I'm starting to hear that number is creeping up closer to like $250, even $300 these days. So if you think about your margins and stuff like that as an integration company, every time you roll that truck, it just adds up really quickly and gets very, very expensive. Another great thing is Murideo in general, we're completely agnostic when it comes to brands and manufacturers and model numbers and things like that. We care the most about what's coming into the TV or what's coming through the distribution system or whether the cables work or not. So when you're using these tools, just remember that if you're maybe have a competitor in your area who's the integrator and they don't have these tools, you can kind of present that as part of your pitch for your company. We're going to be able to fix problems quickly. We're going to be able to fix problems easily, and it's because of these tools. And I've been there in the field before too, guys, where you go visit a customer 2-3 times, and next thing you know, it's been 2 weeks or so, and their system's still not working correctly. It can be a super big headache, and we want to avoid that. And again, like I kind of mentioned before, no more guesswork. You know exactly what's coming into through the system into the TV. You know exactly what signal's coming from the source. So there's no more of this, oh, let's swap out the receiver, it must be that. And then of course the problem still exists. So just a few things. The kit itself, we'll take a quick look at that. And what you're seeing on the screen right now is it's a 2-piece system. So you have a generator and an analyzer. And give me just a moment and we'll take a quick peek at those. One thing that you'll notice, and I do want to make sure that we call this out, because I've gotten this call before from people who are new to the company, or maybe they're buying these tools for the first time. We didn't do this before, so I understand why it may have been confusing. When these ship from the factory, guys, there is a protective plastic, almost like you'd see on a cell phone. So just make sure you peel that off, and it'll take care of what might look like any scratches or anything like that may have come from the factory. But again, it's a two-piece system with a generator and an analyzer, and they're both very similar to each other. What I love about these guys is that they're battery powered and they're handheld. So when I'm walking around a job site trying to troubleshoot things, I don't have to, drag around a test monitor with me or anything like that. I've got the tools right here in my hands. One thing you'll notice about them that I love, you have a nice LCD screen up here, so you can see exactly what's going on with the generator and the analyzer. Nice big buttons, very easy to use. For example, we will look at this in a minute, but when you're looking at, say, the 8K button and you press the 8K button, you're going to see all the available 8K resolutions that you can put out into the system. So let's take a quick look at one of those menus just so you can kind of see, get an idea of what that looks like. So on the generator, and this is a cool little trick too that we'll kind of cover. On the generator itself, you'll see I'm in the 8K menu right now by pushing the 8K button down here, and now we can see all the available resolutions that we have for 8K. A cool little trick when you're using these tools, if I take the 8K button and I press and hold it, the generator is going to max out its bandwidth, and we can start to generate these really high bandwidth signals through a system. So you see right now, I press and hold the 8K button, and we're putting out 8K 60 FRL, 4 lanes, 8 gigs apiece. So very easy to use. Like I said, what's nice about these tools, I say this a lot, but it's very true, is that you don't have to be an engineer to use the tools. Being able to just plug something in, push a button, see what's going on with the signal. You're expecting 4K or 8K to come through, but only 1080p is coming through. You can take the tool and start moving it down the chain and figure out what's going on and why the system's not behaving properly. So let's keep going here, and we'll look at a few different things. What's new about the kit, which we, again, this is an upgrade from the 4K version. We're now at HDMI 2.1. It had to happen. We're dealing with more and more HDMI 2.1 products, and going forward, that's all it's going to be. We're going to be able to test HDMI cables up to 40 gigs. That's very important right now. And this is going to sort of sound like a broken record here, but if you remember back in the days of 1080p, upgrading that to 4K, we had a lot of installations out there where the HDMI cables that were already buried in the wall were not up to the task of doing 18 gigabits per second. So one of the biggest reasons why people are attracted to this kit, because you can test your HDMI cables for bandwidth and to make sure they're actually working before you put them in the wall, or if it's a retrofit job, before you start hooking up the components, you can figure out what the condition is of the cables that are in the wall. We're going to be able to test displays for HDMI 2.1. That's really important right now. If you might be let's say you're in a bar, for example, or a restaurant, and you've got a TV way up in the air and you don't know its capabilities, we're going to be able to plug in the generator, run through a few different resolutions, and pretty quickly you'll be able to figure out what resolutions and what formats that the TV likes. Same thing for repeaters. We're starting to see some 8K HDMI 2.1 AVRs out there already. There might be an older AVR in a system that you're working with. We want to be able to pump these high bandwidth signals through the AVR to make sure that it can actually handle it or not. That'll help you make a sort of an educated decision on what to do with that system. You could bypass the receiver. Ideally, you'd upgrade the receiver to something that can handle the signals that you're trying to pump through it. That's not just AVRs. Think about extender kits or matrix switches. That all holds true. We can also take a look at what signals are coming out of an HDMI 2.1 source. So let's say you do have one of those really high-end graphics cards from a PC or just anything that's really high bandwidth that's doing things like 8K. We want to make sure that when we hook up the analyzer to the source, that it's actually outputting the format that we want. You might not be able to tell this yet because maybe the TV hasn't shown up yet, but you're building your rack and you want to be able to take the analyzer, plug it into all your sources and make sure the sources are outputting what you're expecting them to. If not, you can go ahead and reconfigure those. That way, when the TV or projector does show up, boom, you plug it in, you fire it up, and it's ready to rock and roll. From there, you can start making your adjustments and make that customer happy. Of course, we're talking about sources, TVs, things like that, but don't forget that these test tools are not just designed to test one or two things. We can test a full signal chain for anything up to HDMI 2.1. And there might be cases now, guys, where maybe somebody has a really old AVR. The biggest example of this I can think of, and I see in the real world, somebody has a really high-end AVR, they love it, it was really expensive, it sounds great, they know how to use it. We need to be able to test that to make sure that it can do even 4K. You know, if it's something that's, you know, 10, 15 years old, it might not even be 4K capable. So again, being able to, you know, take the generator and the analyzer, see if 8K is coming through, maybe it's not. Okay, now we can change the generator to output 4K. Okay, the signal's still not coming through. Then we change the generator over to 1080p and boom, now the signal's coming through. Again, now you have this informed decision to make of, you know, what do we do in this situation? Do we bypass it or do we replace it? So we'll take a look at some bandwidth. This is probably going to be new to a lot of people. When we were dealing with traditional HDMI up to 18 gigabits per second, you would see something called TMDS. That was how the audio and video signals were transmitted in the old days, we'll call them. Today, we're looking at something called fixed rate link. So when you see that FRL acronym, that's what that stands for. And there are different versions of FRL. So you'll see here, starting with FRL1 all the way up to FRL6. If you look at FRL1, you're still going to be seeing some, you know, quote unquote normal resolutions like 1080p, 4K, various frame rates anywhere from 30 up to 120 with, you know, several different choices here for chroma subsampling, a few different choices here for bit depth. Of course, that'll be different if you go from 4K to, or I'm sorry, 1080p to 4K, and total bandwidth. So you'll notice here with like FRL1 and even FRL2, you know, these bandwidth requirements are still going to be 18 gigs or below. So a lot of this stuff is going to change. Is going to stay the same. What's going to change is when we get into anything above 18 gigabits per second. So we start looking at 24, and then FRL4, we're up to 32 gigs. FRL5 is where we're living right now with the test equipment. And you'll see that there are, you know, several instances here where it's 40 gigabits per second. And I do want to call this out because we've gotten this question many times with the 8K Murideo 6G and 6A, and also the 8K 7G. Is, you know, people say, well, why only 40 gigs? And the important thing here, guys, is to remember there's really two reasons. A, we're not going to see anything over 40 gigs for years. So for any manufacturer to put in a 48 gig chip, it just skyrockets the price. And it was just sort of unnecessary. Now, when we get into 48 gigs, you know, 4, maybe 5 years from now, then of course we will have something that can support 48 gigs. But I just do want to point out that not to worry about it, because look, there's only about 3 formats that are over 40 gigabits per second. And even when you talk about compression, the only signals that are at 48 gigabits per second are like 10K 120. So again, we went with 40 gigabits per second, like a lot of manufacturers have. Just to save some money. You know, we didn't want these tools to be, you know, $5,000–6,000. We definitely wanted to avoid that. So a little bit about FRL. We have a bandwidth chart available on the website, murideo.com. You can print it out. I have mine hanging on the wall, so I can always peek back at it for reference. But again, you see the bandwidth requirements here. We've gone with FRL, we can go anywhere from 9 all the way up to 48, which was nice. And remember, TMDS is only limited to 18 gigabits per second. So if you have a customer who's expecting 8K, then we have to start looking at a system with HDMI 2.1 everything, because we need to use the FRL system. Just a sort of more of a quick glance at the bandwidth chart here for each version of FRL. One thing I find interesting here with HDMI cables, traditionally with 18 gigabit or lower HDMI cables, is we would use again TMDS, and inside of that cable there are 3 pairs of wires that carry the audio and video signal, and that was fine all the way up to 18 gigabits per second. And that's still supported in FRL 1 and 2. Where things get really fun is we start talking about FRL 3, 4, 5, and 6. What they've done with the HDMI is they've turned the clock channel into another channel for data. So that's why we start to see now there's 4 lanes of data. Now we can start getting these super high bandwidth signals. So just a little bit about that. Again, that's on the website, that's printable. You can certainly check that out if you like, totally for free. Okay, so the first thing we're gonna look at here is how to test an HDMI cable. And I've got a few different cables here. I've got one that's completely unknown. There's no markings on it other than like CL ratings and things like that, no bandwidth markings. I also have a couple of fiber-based HDMI cables, which we call AOC cables, active optical cables. And then I have a couple others here too that we'll test them together, and we'll see what's going on with those. So let's fire up the camera here, and you guys should see me. Let me know if you do not. And we're going to take the generator and analyzer, And first, I'm going to take this unknown cable with no markings on it. I have no idea who makes it, no idea what its capabilities are. Again, it says where it was made, CL rated, so it can go inside the wall, but it's very vague. We have no idea. So very easy test. We're going to take one end of the cable and we're going to plug it into the generator. To turn the generator on, we're going to press and hold power. Same thing with the analyzer. Press and hold power. Once both devices fire up, we're ready to do the test. So now I'm going to take the other end of that unknown, who knows who HDMI cable, and we're going to plug that into the analyzer. Now, I'll give you guys a little bit of a closer look at this. It'll be easier to see it. So right now, whoop, turn that volume down. I'll cover what that beeping is here in a little bit. But on the analyzer, we look at the buttons and we look at the front panel, and there's a button here that says cable test. So we're going to press the cable test button, and this is one thing that will be different if you're used to the 4K kit. The number one memory slot here for the cable test is for 40 gigs FRL. You'll notice there's also for 32, and then we get back down into 18 gigs, then down to 14 gigs, then down to 9 gigs, then down to 4.5 gigs. One thing you'll notice on this kit is in a lot of instances in some of the menus, there are more selections than what's on the main screen. So don't forget pushing the down button. That might give you a few more selections. So we're now able to test cables anywhere from 40 gigs all the way down to 1. So let's just start with that 40 gig. Again, I've not tested this, so I'm going to learn this with you guys. Can this cable pass 40 gigabits per second? So we're going to highlight number 1, press OK on the analyzer. We're going to wait about 15 seconds or so and see exactly what's coming through. Now, what might look a little bit different to you is probably similar as well, but when we're running the cable test, the first line in there is a check the 5 volt. So that's telling us that there's something on the other side. Great. If there's no 5 volt, there's no way that the test is going to start. So what we had on the old 4K kit were 3 data channels, 0, 1, and 2, and those were the 3 TMDS lines we kind of talked about before. Now, because we're talking about FRL, the data channel only comes in as 1 channel, and it shows 0 errors. The DDC channel passes, great. We're going to get things like HDCP and EDID, and then the hot plug passes as well. So guess what? This is surprising to me, probably like it is to you too. This is an unknown cable. I just grabbed it out of a bin, and guess what, guys? It's passing 40 gigabits per second. That's pretty cool. I was not expecting that. So let's do this. We're going to take another cable, and this is one of the AOC cables I mentioned before, active optical cable, and we're going to plug this in, and we're going to do the same exact test. We've got the analyzer on one end, and we've got the generator on the other end. Now we're going to take that analyzer and press the cable test button again. We're going to pick the top slot for 40 gigabits per second, and we're going to sit back and wait, and we're going to see if the cable passes. Again, this is a random cable. I grabbed it out of a bin. I don't know if it's going to pass or not, but we're going to find out here. And one thing I do like about this, the cable test specifically, you know, I'm always thinking about those jobs I've been on before where, you know, we're going to go do an installation and there's 25 HDMI cables in the installation. I'd much rather do this testing before I take those cables on site. So this is a really good exercise to not only get used to testing cables, but also, you know, you don't want to take a defective cable out to a customer's home. So it's a pretty good idea to test all your cables before you go out. Something I'm always a big proponent of. Now, if we look at this cable at 40 gigs, it failed. We've got a 5 volt, that's cool. But for the data, we have no signal. The DDC and the hot plug both fail. So this cable is at the very best questionable. So let's go back into the cable test menu. Let's knock it down to 32. See if it can pass at 32. Now, again, this might not be pre-installation. This might be an instance where you're on site doing a retrofit job. Cables are buried inside the wall, or maybe they're zip tied in a rack and it looks really good. So you don't want to tear it apart unless you have to. But, you know, again, test all these cables beforehand in a retrofit job, test them as you go. That cable failed the 32 gig. Wow, we might have a flat out defective cable here. Let's see for sure. Let's go all the way down to 1 gig. and let's see if it passes that. Now see, now that we're back down to 1 gig, we're under 18, we're not using FRL anymore, we're back to TMDS, and now we're back to the 3 data channels, 0, 1, and 2. So hopefully, fingers crossed that they pass. If they don't, that means we tested this cable for 40 gigs, we tested it for 32, and then we skipped all the way down to 1 gig, and look, this cable completely fails. So I don't know if this cable is physically damaged in some way. It is an AOC cable. Those have small chips, a little bit of electronics in each end. So there is a chance that maybe something's going on there. But guess what we do with this cable, guys? It goes into the trash bin, and we know we're not going to use that cable for anything for the rest of eternity. So cool. If there's any questions about the cable test, it's super simple, super easy to do. Only takes about 15 seconds. Feel free to type any questions that you might have into the question box. Okay, let's look at a few more slides, and then we'll do a few more exercises together. You guys should see the PowerPoint again, and let's move on. Okay, we're going to start talking about now troubleshooting, either whether it's full distribution system. I have a few sources with me as well. I have an extender here with me as well. So we'll start taking a look at those individual things to see how we would test those using the Fox and Hound. So what I want to point out on this screen, and this is, I mean, guys, this is really like, this is maybe the bulk of it right here. If we look at the generator is set to 8K60 FRL, 4 lanes, 10 gigs. So that's also with the SMPTE bar pattern. So we pump that signal through an entire system. This could be an AVR, or it could be several things in the line. It could be a matrix switch, then an AVR, and then an extender. You know, it could be a combination of many things. So when the 8K60 signal comes through the distribution system, it shows up on the analyzer with the SMPTE bars. Okay, that's good. That means the signal is getting through. But then on the analyzer, if we push the info button, look at what's actually coming up. We get the test pattern, that's awesome. But look at what's coming through, 3840 by 2160, 60 frames per second. So if I have this set to 8K and all that's coming out is 4K, what's going on? And that's the $1,000,000 question. So we know we have 8K over here. We know we have 4K over here. Now we can start dissecting the distribution system to see what's going on. And don't forget, guys, part of the system are the cables. So when we start talking about testing individual devices here in a few slides, I've got a cool little diagram to look at. We can't just think about the cables or just think about the different components in the system. We have to look at it systematically, and that's where we start doing our very fine detailed troubleshooting. Another thing I like about this kit, we do this a lot when we do ISF classes or the academy class that we do. In a lot of those cases, you know, we might have 4, 5, 6 TVs that we're going to be using for labs and whatnot. This is something that I do, and it easily translates for the integrators out there. So imagine you're about to do an installation, but the projector hasn't shown up yet. This can be common. Maybe it's on back order, who knows? But you have everything else ready to go. So your idea as an integrator is, let's build the rack, let's run the wires, let's get it to a point where all we have to do is hang the projector and plug it in. Well, how do you know what's going on throughout the system and what kind of signal is getting up to where the projector is going to go? We don't know yet. So what's nice about this is you can take the analyzer and you can plug it into that HDMI cable where the projector is going to go. You can set up your rack, you can set up your distribution system. That way, when the projector does show up, you can mount it, you can plug it in, check a few things. Because you've already done the pre-installation check, you know that the signal coming into the projector is what you want. You've eliminated a ton of headaches and a ton of time troubleshooting there, which is really nice. Something else I like, and we'll talk a little bit more about later, is EDID management. We can emulate EDIDs, we can copy EDIDs. There are some built-in EDIDs. We'll talk about that a little bit later, but one thing that might be nice to do is maybe the projector is there, it's just not installed yet, it's not mounted yet. Plug it in, fire it up, read the EDID, copy the EDID. Now you can get the rack set up, because now you're using the analyzer like you would be using the projector. But again, don't worry about that too much right now. We'll go ahead and move on. So HDCP, another big problem. I know everybody loves HDCP. It's our favorite thing in the world. It's the easiest thing to work with. We all love it. Just kidding. This is still a big problem. This has been a problem since HDMI has been a thing. So one of the things that we want to look at is, can the distribution system, or can a product, or does a product, are these things updated to support the latest version of HDCP? You guys know as well as anybody, when you're in a system that some of the components are a little bit older, some of the components are a little bit newer. You don't know what can support what. So we have to be able to emulate any version of HDCP that's out there to make sure that different devices or the entire system can actually handle it. So one thing I want to take a quick look at, we'll take a look at the generator. And on the generator, there is a button that says HDCP. So we're going to press that button to get us into the HDCP menu. And look how simple this is. We can turn HDCP off. We can look at version 1, or we can look at version 2. Now, something that's interesting, this is a good tech tip and something that's I don't think a lot of people realize yet. I found this out by accident. Notice how it's not letting me pick HDCP 1.4. There's a reason for that. So when you're using FRL, when you're doing anything above 18 gigabits per second, and now we're in the FRL mode, you have to use HDCP 2.2. So keep that in mind, keep that in the back of your head. If you're having HDCP problems, remember with FRL, you have to use HDCP 2.2. So I can't select HDCP 1.4 right now because I have an 8K resolution, which is FRL, set on the generator right now. So just a little side tip for you. So if I turn HDCP off on the generator side, I can at least see if signal's getting through. Okay, it is. That's awesome. Now we can go to HDCP 2.2 and choose that and still see if there's signal coming through the system. If there is, great. That's super easy. You know that all the devices, everything in the signal chain is HDCP 2.2 compliant. If you don't get a picture, or the picture is flashing, or you get snow on the screen, like an old staticky TV with no channel playing, you know that there's an HDCP problem. You can now take the generator or the analyzer, work your way up or downstream, and start testing each individual device. So this is really cool. It makes HDCP troubleshooting a lot simpler than it used to be. You know, there's a story that I always like to tell. When Avatar came out on Blu-ray, there was a big problem with older components not being able to do HDCP 2.2. So when people got that movie, they tried to play it for the first time in their Blu-ray player, it wouldn't play, and it just caused like havoc everywhere. The good news is in those days, you had to hardwire or use a blank disk or a thumb drive, but in those days you could update the firmware of those older players, and then all of a sudden Avatar would play and everybody was happy. So HDCP troubleshooting becomes a lot easier when you start looking at the generator and the analyzer, the Fox and Hound kit. Now on the analyzer end of things, I'll take an HDMI cable here, and you can see in the analyzer exactly what's going on with HDCP. So we're going to plug in to the generator, and then we're going to plug in the other end into the analyzer. And I'll switch cameras so you can see the analyzer a little bit better. Now on the generator, I'm going to generate a signal with no HDCP. Again, we just want to see if there's a picture and sound getting through the system. So now on the analyzer, we're going to press the info button, and this gives us all the information that we need to know for what's coming into what this could potentially be a television or a projector. So right now it's coming out 480p, 60 frames per second. The chroma or the color space is RGB, and it's at 444. We're an HDMI connection. HDCP, there is no HDCP. That's good because on our generator we have HDCP turned off. We look at the color depth is 8-bit, whether HDR is there or not, a few different things about the audio, all good stuff, right? So now if I go back to the generator and I pick HDCP 1.4, we're going to re-handshake with the analyzer, and in just a moment, everything's going to sync up. We see the resolution, we see the test pattern, that's good. Push the info button, and boom, there we go, HDCP 1.x. That's what I have the generator set to. Excellent. Let's take it one step further. Let's go to 2.2. In order for me to do 2.2, don't forget, we cannot do a 8K 2-point run resolution. So now we're going to go HDCP 2.2. Analyzer is going to resync with the generator. And drum roll, please. We're back to 1920 by 1080. I set it like that on purpose. And we press the info button. And now we have HDCP 2.x coming through. So, of course, right now, just for demonstration purposes, there's nothing in between the generator and analyzer. But if there were, you can start to see how valuable this stuff can be. There looks like there's a question. First one of the day. Awesome. Nick Mears, hey, how are you? Nick says, actually there's two Nicks. Nick Harper says, since we're talking HDCP, would this be able to check Pro IDIOM? Nick, I gotta be honest, that is not familiar to me. If you wanna maybe elaborate a little bit more, maybe something will jog my memory and ring a bell, but I might be learning something new today, which I try to do every day. So Nick Harper, if you'd like to go a little bit deeper into that, go for it. If not, we'll do a little bit of research offline and you and I can connect and we can figure out the answer to your question. But thank you for the question. Keep those questions coming in, guys. Don't be shy. Okay, let's move on a little bit. Oh, he replied, okay, healthcare or large scale RF or distribute protect. You know, Nick, I'm not sure. Let's talk offline and we'll get that answer. We'll get that answer for you as best as we can. So, okay, let's move back. We'll look at a couple of more slides and we'll do a few more tests. I talked about HDCP. I said this, but I didn't show it to you. One thing that there's really three good indicators that whatever is going on in the system, you might have a flashing picture, you might have no picture at all, or you might see on the TV this what we call snow or static. Again, this reminds me of being a little kid and turning on a TV channel that didn't exist. You just had static on the screen. So those three things that I just mentioned, a flashing picture, no picture, or snow on the screen, that could very, 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 very easily indicate that there's an HDCP problem. So again, we want to be able to test different versions of HDCP. We want to see what's coming out of sources and repeaters, and we want to see what's getting into the TV. So using the analyzer, if you plug in the analyzer at a point in the system and you see that snow, you know that somewhere in that system up to that point, there's some sort of HDCP mismatch or some sort of device in that doesn't support maybe the latest version of HDCP. So just keep that in the back of your head. Snow is a good indicator, no picture or a flashing picture. Okay, EDID, this is cool. This is one of the biggest lifesavers. When I talk to the installers who have a kit like this, they really, really love this feature. And it's something that I find super, super handy as well. It's one thing to be able to read the EDID of a display. You can see what its preferred timing is. You can see what it's going to ask for from the source or the next thing in the line at least. And it's great to be able to see that information. What makes it really powerful is copying that EDID. So I've got a little bit of a kind of a setup here I want to show you. We're going to flip back over to the camera and you guys should be seeing the analyzer right now. So I have a TV in here from a popular manufacturer, and we'll take a look here at the TV's EDID to see exactly what it wants. Now I'm just very simple here. I've got the analyzer and I'm plugging an HDMI cable into the analyzer. The other end of that HDMI cable is plugged into an input on a TV. So we're not going to get a signal right now because we have an analyzer connected to a TV. What we want to do is push this EDID select button, which is right there. And that's going to give us a list of EDIDs that are built into the analyzer. So if you're not sure what the display's capabilities are, maybe you can't get to it. There's a million different reasons why you might not know what the TV's EDID is. But you can sort of, I don't want to say guess, but you can try different EDIDs to see how the TV responds. So, or I'm sorry, to see how the source responds. So there are some built-in EDIDs here. The first one is 8K FRL 10 gigs. We know a little bit about that already. The next one is 4K 60. Then we have 4K with 420 chroma, 4K 30, 1080p, 1080p with 3D and no 3D. And then there's a couple of user memories here. So number 7 and number 8. So the first thing that I want to do is push this button that says active EDID. Now it tells us exactly what we're plugged into right now. The manufacturer, actually that's pretty interesting why it says that, but that's okay. Actually, you know what? Let's do this first. Let's first copy the EDID and then we'll read what it is. That might be a little bit easier for us here rather than try to read that tiny print. So if I want to copy the EDID from the TV that I'm plugged into right now, I have two options, A or B. So in this case, I'm just going to press and hold A. And then on the screen, it's going to say copy EDID to buffer A, and we press OK. So now memory slot A, oh, it failed. Oh, okay, we got to do some troubleshooting here. This is interesting. If I copy the EDID, let's just try maybe B to see what's going on here. See, this is what happens, guys. This is what happens when you're in a live environment. We'll try buffer B. Ah, it failed again. Oh, okay. Well, of course, here we go. So if I were able to copy the EDID from the display, I don't know why it won't do it right now, but that's why we have the tools. Now, if I press the EDID select button, down in memory slots 7 or 8, that's A and B. So if I choose one of these, number 7 is now memory slot A. So number 7 is what I'd want to choose. Now the analyzer has the same EDID of the TV or the projector that you're plugged into. So now I can take the analyzer and walk back to the rack or walk back to where the source is, and I have this TV that I just read the EDID from, or that projector, in my hands. So now I can go back to the source, I can plug into the analyzer, and we can see what kind of signal is coming out of the source. What kind of signal does the source put out? Well, it depends on the EDID, right? So if this is now that TV that's hanging on the wall, I don't have to carry around a test monitor. I don't have to walk the source over to the TV and try plugging it in. This is now that TV or that projector. Again, battery operated, you can carry this around, no big deal, super easy stuff. Very, very, very useful to be able to copy the EDID. Okay, let's take a look at what's next. And I appreciate the questions, guys. Keep those coming in. Dustin chimed in about the IDIOM for hospitality, medical. Okay, cool. I love learning new stuff, so that's awesome. I'll do a little bit more research on that, and we can maybe get Nick a solid answer on that. But yeah, thank you, Dustin, for looking that up. And again, thank you, Nick, for the question. And it does look like there might be another question here from Torsten, and thank you for joining. And we see you here all the time. He is a regular. Jason, is it also possible to bring your own test patterns or short videos on the Fox and Hound? No, we don't have the capabilities of that. Again, we had to keep things limited memory-wise and chip-wise to not make this tool crazy expensive. But you know what you can do that on is the 6G and also on the 7G. So if you're looking to do any custom test patterns or even any custom resolutions for custom applications, that's when you want to look at something like the 6G. Thank you for the question. Okay, cool. There's a few more questions that came in. We'll get those at the end because they're sort of just general questions. Lucas had a couple, but again, guys, feel free, keep those questions rolling in. Okay, if we flip back over to the PowerPoint, we are there now. That's great. Just a little bit about EDID if you're not familiar with it, or maybe you're new to this. EDID is a very simple concept, and it's funny because up until HDMI 2.0, EDID wasn't terribly important. I mean, it wasn't important to a point where you like had to read it every time, which we're kind of at that point right now. Pre-HDMI 2.0, remember what we were dealing with. We were dealing with DLPs, we were dealing with plasmas, we were dealing with LCDs, and you know, in those days, things topped out at 1080p, and we pretty much knew everything was 1080p. So, you know, being able to copy the EDID and things like that wasn't all that important. But now it's more important than ever. I know you hear that all the time, but it's true. So a little bit about EDID. It's going to come from the TV first, or the projector first. The EDID is basically the projector or the TV, we'll just say display. The display is saying, hey, I'm here. Here's what I'm capable of. Please send me that. Here's what also I'm capable of. I can do this, this, or this. So then the source sees that and says, oh, you can do this or that. Great, that's what I'm going to put out. That's how EDID works. You don't have to really get too more complicated than that. It tends to be overcomplicated a lot, but it doesn't have to be. So we'll take a look at a simple system up to a more complex system. You guys will get the idea right away. We don't need to spend a ton of time here. So where does the EDID come from in number one? It's always going to come from the sync device, aka the display. System number two, we have a source, an AVR, and a display. The EDID is going to come from the display, and it's going to tell the AVR, hey, here's what I'm capable of. The AVR, guess what? It has an EDID because it has an input. So if the EDID from the display says, I want 8K, and the EDID from the AVR says, I want 4K, guess what the source is going to put out? It's going to put out 4K. So if the EDID from the display device and the EDID from the AVR don't match up, you don't know what the source is going to do. It's unpredictable. Number three, same thing, just add in another component. The EDID comes from the display, then there's an EDID in the AVR, then there's an EDID in the matrix switch. What's the source going to respond to? The next thing. So we have to keep all the EDIDs in line. This is why it's so important to be able to copy the EDID. Take a system like this, we can copy the EDID from the display, then we can plug the AVR's output into the analyzer, and we can see how the AVR responds. If it responds the way we want, great. We can now take the analyzer, connect it to the output of the switch, see how the switch responds. So you guys get the idea. You can go from device to device to device, all the way back to the source to see what's going on. 4, 5, and 6, I don't want to bore you with that. Same thing, rinse and repeat, but just with more devices in the signal chain. Okay, let's move on. Oh, here's a diagram of kind of what we just talked about. More visual. I know most of us are visual learners, so we'll show you instead of talk about it. So the problem that we have in this system is we have one display that's, in this case, 4K 60 with HDR. We have another display that's 1080p. This is maybe a bedroom TV. This is maybe the main TV in the living room. Who knows? We have a matrix switch, and we also have 4 sources. So where does the EDID come from? Again, it comes from the display. So if this display tells the switch, I want 4K 60, this display tells the switch, I want 1080p, what does the switch do to make sure that the system works? It's going to take the 1080p as the lowest common denominator. So your 4K sources are now outputting 1080p. Your 1080p source will, of course, output 1080p. So if you don't have EDID management in your switch, who knows what's going to happen with the system? It might not give you a picture at all. But again, being able to read the EDID from the display, see what the EDID is of the switch, then you can figure out how to configure the source, or the source might respond accordingly and put out what you expect it to. Another system, now we're dealing with a managed switch. This is 4 inputs, 2 outputs, just like before. Now in this case, we still have that same 4K 60, 8K 60, whatever it is, display. That's putting out a 4K EDID to the switch. This TV is still 1080p. That's telling the switch I can do 1080p. Now in a managed system, you can tell the, in this case, you can tell the switch, hey, for input 1, I want to use this EDID. For input 2, we want to use this EDID. Input 3, this EDID. But guess what? Input 4, we're going to use this EDID. This way, all the sources are showing 4K 60 in this case on the 4K 60 display, whereas the 1080p source is going to put out 1080p because of the EDID. So you can see, if you had a choice between the two, would you rather have something like this where the system is compromised and knocked down to the lowest common denominator, or would you rather be able to do it like this where every display in the system is getting the proper signal? Again, this all depends on the devices in the system. There are extenders out there that have EDID management. There are plenty of matrix switches out there that have EDID management, but if you don't know what that EDID is and you don't read it, you have no idea. So I wanted to show you this one. It's pretty cool. This is actually from an 8K LG OLED. This is going to be a very similar story to what you guys heard when we started going into 4K from 1080p. This is from an 8K LG. Now look at what happens. We read the EDID from the 8K LG, and what does it ask for first? 4K 60. Why does it do that? Because the source connected to the TV might not be able to do 8K. So in this case, the TV came with a preferred timing of something that almost everything can agree with. So there might be something we have to do to the TV to make the EDID ask for 8K. Super simple. It's usually in the menu. You usually have to just flip a switch. We saw this with 1080p. When 4K TVs were new, the preferred timing out of the box in the EDID was 1080p. Why? Because everything worked with it. It wasn't a big deal. So again, if I plug in the analyzer into the TV and I press the EDID button to see what the EDID is, if this EDID shows me that it's 4K 60, but I want it to be 8K, now I know what to do with the display. You probably have to go in and change a setting or two. Okay, moving along. We'll talk a little bit about troubleshooting an entire system, device by device. Sort of teased it before, but now we're going to look at it. Again, the generator is 8K 60, the analyzer is only 4K 60. Why is that? This is a good diagram. This might be, what we would call a, normal, everyday, straightforward, simple system. You have a source into a matrix switch. This could also be an extender. Then we go maybe HD base T or AV over IP, and then into the display. So this chart is on our website. It's free. Feel free to download it, use it as a reference. But the way we have it set up here is all the green boxes are where you can put a generator. All of the purple boxes are where you can put an analyzer. So if I'm troubleshooting a system, I can start here and work through, or depending on the problem, I can start at the display and work my way backwards. And just depending on which way you're working, that's when you could use the generator or the analyzer. So we'll take a quick peek at that. I actually have an extender kit here. So let's do this. I have a transmitter on one side So here's how I would set this up if I were on site somewhere. I'm going to take the generator and we're going to plug it into the input on the HD-Base-T transmitter to the HDMI in. Then we have the category cable over here to the HD-Base-T receiver, and the output of the HD-Base-T receiver. See what I go through for you guys? I'm all tangled up here in cables. We're going to go into the analyzer, make sure everything's powered on, and we're going to take the generator, and I'm just going to press and hold 8K. The generator is going to pump out all the way up to 40 gigs when I press and hold 8K. So we're set to 8K right now. We've got lights on the transmitter for HD-Base-T. We have lights on the receiver for HD-Base-T. But guess what? Nothing coming through the analyzer. So we know that this switch, this extender is not going to be able to handle 8K. So what do I do next? I go down, right? So now we go into the 4K menu. Let's just keep it simple. We'll pick 4K 24, which is, almost everything in Hollywood. And on Netflix now too, everything, even stand-up comedies are 24 frames per second. So, oh, there we go, boom. Now on the analyzer, I've got my color bars. I push the info button and I've got 4K 24. That's how we set it at the generator. So within, what is that, 30 seconds, maybe a minute at the most, we know that this extender can't handle 8K. Super, super easy. Imagine you're on site, the extender's Velcroed to the back of the TV, the receiver is at least, the transmitter's wrapped up in a rack somewhere. You don't have to tear things apart, guys, and that's really one of the most important things. Okay, cool. Any questions lately? No? Okay, cool. We got a few more minutes. Let's keep moving along here. Okay, again, that diagram, super helpful. I love it. It's on the website. It is free for you to use. Okay, now we're gonna look at a source. Super simple. So maybe it's a Blu-ray player, a streaming box, a PC, it could be 10 million different things, as you guys know. One thing I want to do here is I have a Blu-ray player over here in my little mock system. Now the output of the Blu-ray player, I'm not going to bother lifting it up because I'll probably drop it and break it, but the output of the Blu-ray player is going to go to the input of the analyzer. Let's go ahead and plug that in. There's that cable. We're going to plug into the analyzer. Now we're going to take a look at the analyzer. Coming out of that player is 1080p, 24 frames per second, and it looks like there's a icon on the screen, which means it's probably in sleep mode. Let's go ahead and push play on the Blu-ray player, and boom, we can see the content. Now here's what's really cool. Yes, there's video coming through. Excellent, great news, right? Check out this volume button right here, volume up, volume down. Not only can I see the video that's coming through, I can also hear the audio. This is super, super helpful when you're troubleshooting sources or the entire signal chain. Think about all those cable boxes, think about all those cable boxes out there that everyone loves and has no problems with, right? Well, if I plug into the cable box, I can not only see it, I can also hear it, and we get a live preview on the screen there of what's coming out of that source. So if I'm expecting 4K or 8K to come out of that source, I come over here and I push the info button and it's only 1080p. There's a few things I can check. I can check the output configuration of that source. This sounds really silly, but I've done it myself. I'm guilty, but maybe you accidentally put in, or maybe there is a 1080p disc in the player. So could be a million different things. You could have a 1080p disc in the player, but the player is set to output 4K. There's all these unknowns and all these questions about what you're actually doing. Plug in the analyzer, hit the info button, and you can see exactly what's coming through. It makes it very, very easy. Okay, let's kick back over here and look at a few more things, and then we'll get to some more of the questions. Talked about sources, we talked about displays, repeaters. We kind of showed you that with the extender kit. This could also be a distribution amplifier, aka a splitter. A repeater device can also be an AVR, a million different things. But again, generator goes to the input, analyzer goes into the output, pumps some signal through, see if the thing in between the generator and analyzer can handle the signal that you want. And again, if it comes through, great, push the info button and make sure that what's coming out of the generator is what's coming into the analyzer. Don't forget the HDMI cables. Those are part of the system. So if I'm getting no signal on this end, maybe this device can actually handle 8K and you're putting in 8K and you're expecting 8K and you get no signal. What the heck is going on here? Guys, don't forget, test your cables. One of these cables could not be capable of doing the 8K stuff. We looked at extenders already. HDR is another important one. If you guys aren't doing HDR by now, this is one of those things where if it's done correctly, it looks awesome. I've been living with it in my own home now for several years. I'm finding myself watching things I normally wouldn't care about just because it looks really good. If you can do HDR correctly, you will blow away your customers, and that's really the whole point here. So if I kick back over to the generator, we'll take a quick peek at that, and I will show you on the generator. When we take a look here at the generator, there's an HDR button right here down in the bottom. I'm looking at this upside down, so forgive me for the pause. And very simple, guys. Look, we can turn HDR off, we can turn on HDR10, or we can turn on HLG. So again, this is helpful. If I turn HDR off and I'm getting signal into the display, and then I come back here and I turn on HDR10 and the display is not showing HDR, now I know what to do. Now we're back to the troubleshooting steps of test everything that's in the signal chain. We can even do HLG. We're not seeing a lot of HLG now, but guess what? We will be seeing it very, very soon. The thing I'm most excited about is broadcast and sports. That's what HLG is made for. What's nice about it, it's backwards compatible. So even if grandma and grandpa have an older TV, it's still going to work. So we need to be able to test systems for not only HDR10 but also HLG. Again, we're not using a lot of it right now, but it will be here very soon. And as soon as you guys see live broadcast sports in HDR, aka HLG, it is a total game changer. We had the Super Bowl a couple of years ago in HDR, and it was awesome. It looked very, very good. Common problems in a distributed AV system, or any AV system for that matter. No video. We've got troubleshooting steps for that. This also is available on our website. Feel free to download it and use it as a reference. No video is a big problem. We kind of talked about what to troubleshoot for there. It could be HDCP. It could be that the system can't handle it. It could be an HDMI cable can't handle it. No 4K, kind of the same story. If you're expecting 4K at the display and it's only 1080p, or you're expecting 8K at the display and it's only 4K, you can start to figure out what's going on and what's breaking the system with the kit. Incompatible video, this is something that we usually talk about with EDID, and what that really means is when we say incompatible video is that maybe the display is older and it has a 1080p EDID, and that's all it can do, but you're expecting the source to do 4K. That's obviously going to be an EDID problem. So being able to read the EDID, copy the EDID, again, just another very, very helpful tool. Sometimes you see discolored video. Sometimes this could be just a mismatch between color spaces. So for example, if you're using a TV as a computer monitor, but you're sending it a video signal, it might freak out and have a picture on the screen, but it might be discolored. And it can go the opposite way too. If you take a computer that's expecting RGB and you send it video, you might have that same problem too. But if I can take the analyzer and plug it in place of the display that's discolored, I can push the info button on the analyzer and see what's coming in, RGB or video, YCBCR. If it's coming in as something that I'm not expecting, maybe it's a computer monitor, so I'm expecting RGB and it's really YCBCR, I can go back to the source, change the setting over to RGB, and everything should line back up. Again, with the source, we sort of looked at that before, being able to test the sources to make sure they're outputting what you want them to. Again, the most common example is the TVs aren't here yet, the projector's not here yet, and a lot of times in my cases where I use this is, we're setting up a classroom, we've got 6 TVs to unbox. I don't want to unbox them until I know that the infrastructure is set and good to go. A few troubleshooting tips, these are available on the website as well. I'm always taking notes, whether it's on my phone or on a legal pad type thing. I like to draw out the system. I make a little checklist for myself. What have I checked? What is this doing? What is that doing? Have I tested this cable? So, when you're doing troubleshooting, don't get yourself into this like infinite loop of anger and frustration. Test one thing at a time, take your time, you'll figure out the problem as long as you do things in a certain order and you don't skip anything. Always, always, always have some trustworthy HDMI cables on you. Whether they're 18 gigs or 48 gigs, as long as they work, you want to have some, we like to call them the golden sample HDMI cables. And of course, going forward, we would want to do 48. But regardless of the situation, have some cables that Again, take notes. I sort of mentioned that before. Sometimes if you want to simplify troubleshooting, if it's not too much of a pain, you can take the source, plug it in directly to the TV, see if things work then. If they don't, you know it's something with the source or the TV. If things do work, you know it's something with the components or the cables in between the source and display. So just another simple tip. If you're doing a fresh installation, or maybe you're lucky enough that the installers before you ran conduit in a retrofit job, start thinking about fiber. We're talking about 40 and 48 gigs today. You know, we'll have that for quite a while, but you know, when we go to the next version of HDMI, whether it's 2.2 or 3.0 or whatever they decide to do, we might be up to 150 gigs. What's nice about fiber, it can handle all that. If you want to really kind of make the system quote unquote future resistant, just think about putting fiber in as your infrastructure. Test all your cables before you install them. If it's a fresh installation, run conduit, so the next guy that comes behind you doesn't have too hard of a problem. And just, you know, think it out, plan how you're going to tackle the system, how you're going to tackle the problem, and track it down. And, you know, just prepare. Again, have those good cables, have your tools, make sure the generator and analyzer are charged up. You know, they'll last for about 4 or 5 hours depending on your usage. But you know, you don't want to show up to the job site and go, oh, dang it, I need to charge my tools. So just, you know, plan and prepare. It's just like cooking a meal. You just have everything in line before you get too deep into it. Guys, that's it for me. It's a lot to cover in an hour. We do have some really great resources on our website. We have a lot of like how-to things. We have even a couple of little training modules that you can take, and you know, just make sure that you're, you know, understanding all this stuff and that it's all sticking for you. Feel free, check out those resources. They're there. You can check those out anytime. So let's roll back now and look at a few of the questions that came in. And thank you so much, guys, for the questions. I love them. Let's see. Okay. I think Nick Harper's question may have been answered by Dustin. Again, thank you, Dustin, for looking that up. Nick, if you didn't see Dustin's note, just reach out to me afterwards and we'll make sure that's all sorted out. My email is super easy. Any of you are welcome to use this, jason@murideo.com, if you have any questions. Lucas asks, is HDR10 always 10-bit? It is supposed to be. And then he says to follow up, or 12-bit, no 8-bit, right? Yes, that's it. With HDR, with SDR, that's 8-bit. It's part of that standard. With HDR, it should be at least 10-bit. There are some really weird situations where it can't be 10-bit, but those are very, very rare situations. Torsten asked about the custom test patterns. I think we answered that already. And then Lucas has another question about HDR10 Plus and Dolby Vision. We are working on a solution right now for HDR10 Plus. We don't currently have a solution for Dolby Vision, which is a good reason if you want to do Dolby Vision to jump up to the Murideo 6G and 6A kit, because that is Dolby Vision compliant and licensed and all that fun stuff. Michael asks, when will these units be available? Michael, guess what? We have some in stock right now. So if you're interested in a kit, feel free to reach out to me, or you can always reach out, info@murideo.com. We can get you set up with that. For those of you who already have a Fox and Hound kit, or any Murideo product for that matter, maybe it's a little older and you want to upgrade to something new, we have a killer trade-in program that Dustin came up with. Reach out to us if you have older gear and you want to trade that in for the newer gear. We've got a really, really nice plan set in stone for you guys for some really good pricing. Jessica says, thank you, very helpful. Jessica, thank you for coming and hanging out for an hour and listening to me blab away about HDMI and troubleshooting. If you guys have any more questions, I don't want to keep you any longer. We're a couple minutes over now. Again, my email is super easy, jason@murideo.com. If I'm not available for some reason, you can always try info@murideo.com. We also have a live chat on the website. So if you need anything, should be super helpful. Super easy to find us so we can help you with your questions. Lucas, yes, this is recorded. I'll have it up on YouTube. Maybe tonight, maybe tomorrow at the latest, but yes, it will be recorded. It has been recorded. It'll go up on YouTube. I'll tweet out the links and things like that. Thank you guys so much for hanging out. Again, if you need anything, feel free to reach out to us anytime. Have fun out there, be safe, and we will see you next time.